Hello, everyone. Thank you for joining us for another live webinar hosted by EE Tech and All About Circuits. My name is Dale Wilson. I'm the Director of Engineering and Content for EE Tech and All About Circuits, and I'll be your moderator today. Our session is brought to you by Omron and is titled AI in Action, Transformative Technologies for Human Vision Image Sensing. Let me tell you about our presenters. Ankit Juneja attended the University of California, Riverside, where he obtained a Master of Science degree in Electrical Engineering with a major in Real-Time Embedded Systems. He is currently an embedded systems engineer at Omron, providing technical support in the Americas for their sensor product offerings. He has expertise with sensor applications within the factory automation, smart home, building, robotics, and food and beverage industries. Joining him is Patrick Leahy, a business development supervisor at Omron Electronic Components. Patrick has over 11 years of technology experience. He started his career at Omron as a product manager, working 1 year directly with engineers in Japan. He has expertise in bash button, lighting, and component technologies for the casino gaming industry. Patrick attended Lewis University, where he earned his Bachelor of Science degree in marketing with a minor in finance. Following the presentation today, we will have a live Q&A session. You can submit your questions at any time during the webinar using the Q&A section on the right-hand side of your screen. I also want to bring to your attention there'll be several poll questions during this presentation, so keep an eye out for those, as we'd really like to understand your thoughts in these areas. It will also help Omron better understand your needs. We will provide our attendees with a downloadable copy of the presentation and some other resources, including a white paper and 2 data sheets, near the end of today's session. These will be available in the Handouts tab. Thank you so much for joining us, and with that, I'll hand it off to Ankit and Patrick for today's presentation.
Hello everyone, my name is Ankit and I work as a systems engineer. Today we'll be talking about a webinar, AI in Action, Transformating Technologies for Human Image Sensing. So in this webinar, we will be covering this agenda. We'll be talking about some of the trends, challenges, how we can help, and then we are going to go in depth with that with some application examples as well. So before we move forward, you will see a poll question on your screen. If you can answer that, I'll give like around 5 to 10 seconds for that before I proceed. Now, so let's talk about the AI trends in human image vision image sensing. So the first one is real-time image recognition. That is AI models to process and recognize people instantly with high accuracy. The other one is motion tracking, which is enhanced algorithms for tracking human movement. The next one is expression detection. That is AI systems that are analyzing facial expressions for applications in marketing and healthcare. The next one is data privacy, which is kind of managing the sensitive data because that is one of the biggest things these days. And the last one is non-invasive monitoring. That is leveraging any camera-based sensor to monitor health parameter without a physical contact. So these are some of the trends that we have been seeing in human vision image sensing. Now, after we have seen these trends, I want to talk about some of the challenges that people face when they are using AI. The first one and the biggest one is finding a customizable and a flexible solution that meet their specific needs. The next one is a shortage of engineering resources to do the development. And the last one is privacy concerns, particularly hesitation about being monitored and recorded by the cameras in public settings. So these are some of the challenges that people face when they are actually dealing with the AI solutions. So now, how Omron can help? So our human image sensing technology offers a variety of solutions. The first one is OKAO, which is a software library of image sensing functions to better understand humans. And OKAO is a software library, so you can actually customize it based on your needs. So that will address the challenge one that we just talked about in the previous slide. The second solution that we have is HVCP2. That is a module that incorporates 10 different image sensing functions to recognize people's conditions. So that is basically, if you're short of engineering resources, it is like a plug and play solution that you can use. The third one is AM1, which you can see right here, which is a top-down view human body detection software, which is basically this camera solution will go into the ceiling. That means people are not directly, seeing the camera, or they are not, under the cameras at that time. They can see the camera, right? So basically, these three solutions can, help with the challenges that I just talked about in the previous slide. So now let's get deeper into the solutions that I just mentioned. So the first one being OKAO, right? So OKAO, like I said, is a software library with image sensing function to better understand humans. So we have categorized OKAO's solution into four broad categories. The first one being detect, which includes face detection. Then human body detection, we can detect front as well as back of human body. Hand detection, eye detection, and pet detection. In pet detection, we can do cat and dog. The next category is detection in details, where in which we have facial parts detection, in which we have 12 points on the face. Then we have facial parts counter detection to do detailed analysis of the face, in which we have 106 points on the face, which includes the jawline, lip, eyebrows and stuff. The next thing in that category is gaze and blink estimation, which basically will tell you where the person is looking and how much the eye is kind of open and closed, right? So that is gaze and blink estimation. Then the next function is human body silhouette detection. That is basically giving you the outline of the human body. The next category is recognize and estimate function, which includes face recognition. With this software, we can do up to 5,000 users with 10 images per user. So that has a album base of 50,000 with one software, right? And then we have age and gender estimation, which will give you the age in numbers, and then the gender of the person. Then we have smile degree estimation, which will give you the level of how much the person is smiling. Then we have expression estimation. We do have 7 expressions that we offer. 2 of them are hidden that we don't talk about, but those 7 expressions are happiness, sadness, anger, surprise, neutral. Those are the 5 that are available, and then fear and disgust are the hidden one. If you want to use it, you can always extract that from our libraries. And the last one in this category is imposter prevention, which is basically to differentiate between an actual person or a photo or a video. So we have that feature of that as well to differentiate. And the last category of OKAO, functions that we have is adjust category, in which we have two different functions. One is red eye reduction. Previously, you used to see whenever you click a picture, right? You could see the redness in the eye. So we have the feature to remove that redness from the eye. And then we do have a function of OKAO beauty, which is predominantly used in the Asian markets to kind of beautify during your kind of virtual meetings and stuff, right? How you're going to look once you apply a liner or a teeth whitener, so all those things. So these are the kind of list of functions that we have to offer with OKAO. Before I move forward, you guys would see another poll questions. If you can take like a moment to answer that, and before we move forward. So I'll give another, again, 5 to 10 seconds to answer that. Perfect. So next, in the previous slide, I talked about all the functions that OKAO has to offer. So the next thing we have to understand here is what's the order of OKAO functions. Like, for example, you think that you need face recognition for your application, right? So for face recognition, as you can see from the slide, that it is dependent on facial parts detection and face detection. What that means is that if you need to use face recognition, face detection and facial parts detection will be prerequisite, that you would need to have those functions in order for face recognition to work. Similarly, like if you want to use imposter prevention, that is to differentiate from an actual person from a photo or video, you would need gaze and blink estimation function, facial parts detection, and face detection function. So these are this slide talks about the dependency of functions on one another, right? There are some functions which are independent as well. Like for human body detection, you don't need a prerequisite. It is like an independent function that you can use, right? So this basically gives you an idea of how our software is structured, right? Moving on, next we will talk about the requirements of OKAO software as well as the features. So when we talk about the requirements, the minimum hardware requirement we need to run this software is that the machine it's going to be running on, whether it's a embedded device or your laptop or a mobile phone, whatever it is, right? The device has to be 32-bit or 64-bit machine, right? And then the next thing is OS independent. Our OKAO software is OS independent. What that means is it can work with any system that has an OS or no OS. So like you can see, so just to give you a perspective, right? So our OKAO software can work with any platform that you can think of: Windows, Mac, Android, iOS, real-time operating system, RTOS, or any other embedded device that you can think of. It will work with that, right? So that is, the flexibility I was talking about that our software offers. And then let's talk about the features. So we do have three features, with the first one being high accuracy. We have been developing this software for over 20 years now with highly accurate. That's why you can see we have sold over 1.5 billion licenses. And next is the high performance. So basically, we have high performance even at the edge, and we basically target low power embedded devices. And then it works well even in difficult condition, which means that it is highly robust. So these are the three features: high accuracy, high performance, and high robustness. The next, we'll talk about the OKAO demo. OKAO demo we have that are available in two platforms. The first one is Windows and then Android. So now we are gonna look at the OKAO demo, which is on Windows platform.
Now we will do OKAO demonstration. We have OKAO demo available in two platforms, which are Windows and Android. What you see on your screen is the OKAO Windows demo. On the left of the screen is the real-time image from the camera, and on the right side of the screen is the image after the detection has been done. As I am selecting the functions from the function list that is on the top right corner of the screen, you can see the visual detection in the detected image section, which is on the right side of the screen, as well as the raw data of the selected function in the result log section at the bottom left of the screen. As you see OKAO's lineup of function in the OKAO function list for different categories, which are detection, recognition, and correction, that we have discussed before as well, the user has a choice to select and use their favorite functions for their particular application.
Perfect. So this was the OKAO demo for Windows platform that we just saw. So now let's move on to the next thing, which is OKAO Software Development Kit, which is SDK. So like I mentioned that we have a flexibility and customizable solution, which is OKAO. So just to give you a perspective, right? So in order for us to release the SDK based on your request or the customer platform, right? So we would need these kind of information, which is like the OS or platform, the CPU information, compiler toolchain, compiler option, and functions required. So just to give you an example, right? So I have taken like a Raspberry Pi, which is a low power embedded device, right? So that is the OS or the platform. The CPU is Raspberry Pi OS in this case, right? And the compiler toolchain, compiler option, and the functions I requested is face detection and face recognition. So once we have this information, we will prepare the libraries based on this, and then once it is done, we'll kind of release it, which will contain the listed documents, which will be the API document, which will basically talk about how you can call certain functions, and how the structure is how the structure works, right? And then we do offer sample code as well, which will give you an idea how to use that. Then you will have obviously the libraries that we prepared and header files and the README files to better understand, what is, how to use things and how to work with these, right? So this is kind of, what we provide when we release the software development kit for evaluation to the customers, right? The next thing I want to talk about is the OKAO business model flow. Right now, you can see, what we just have discussed previously. It is on this step. That is the second step. That is the technical introduction and demonstration that we can do without the NDA, right? But now, if some of you wants to evaluate, the demo or the SDK, right? Then we would need to have an NDA because this is our proprietary information, right? So in order to proceed further, we would need an NDA. So this that was the only reason to show this, that that we would need an NDA to proceed forward with whether releasing the demo or releasing the SDK. So now that was the basics of OKAO with the demo and the business flow. The next thing I want to talk about is HVCP2 module, which is basically, like I mentioned, it's a plug and play module. As you can see, it has a board and a camera with a flex cable, right? So it can be used with the devices that has no cameras, like a digital signage machine, kiosk, all those things, right? So now, like we see, OKAO had 15 different functions which were categorized into 4 different categories. So in this HVCP2, right? So we have used, out of those 15, 10 image processing functions, as you can see on your screen, right? Face detection, face recognition, age and gender estimation, expression, and then gaze and blink estimation, hand detection, human body detection, and face direction estimation, right? So these are the 10 direction, detection and estimation function or recognition functions that we have taken and embedded on this hardware. And then below are the kind of the function and the results that you would be getting out of it, right? The main thing I want to talk about is the specification of this module, which is that we have 2 different offerings for this HVCP2 module. One is a 50-degree type and the other one is a 90-degree type. So it depends what the customer wants to use, whether they want a narrow angle or a wide angle, right? So the things to note here is that it has 2 different kind of options to communicate. One is a UART 3.3 volt. That means you can communicate with this device through UART, and then the other one is USB. And then if and it's a very pretty worst, like for example, the current consumption and the power consumption, those are very low. Like the current is under 0.4 ampere and the power is under 2 watts. So this is kind of the specification that this module offers. The one difference being this does have face recognition. However, as for OKAO, we could do like 5,000 users, like I mentioned, but this one has 100 users with 10 images per user. So this one module has 1,000 kind of data, 1,000 storage capacity in the album for face recognition. So now for the next few slides, I will like to hand it over to my colleague Patrick Leahy, who is a business development manager, to talk about the application for these products. Over to you, Patrick.
Yeah, thank you, Ankit. As Ankit mentioned, my name is Patrick Leahy, a business development manager here at Omron. So as Ankit went on to explain our technology and a little bit more about OKAO and our facial recognition software, I am here today to talk about some of the use cases and some of the applications that we are seeing out in the market today that is utilizing some kind of facial recognition software. So the first main one is in digital signage or kiosks. So our customers are using it to create a more interactive and immersive experience, which corresponds to the customers who stand in front of their digital signage. Typically, they are using face detection along with age and gender estimation, and they are creating a targeted advertisement for the consumer or the person that is in front of their digital ad space. So with that, they can actually package that to help sell the ad space to their digital signage. They are able to then tell their customer base that they can really hit the target demographic that company is looking to achieve from their marketing campaign. So it really does create a lot of powerful ad data that companies can utilize to make sure that the correct ads are in front of the right demographic at the right time. So with that, you can go on to utilize that data to create audience measurement and have that advertising effect measurement by gathering customers' attributes data such as age and gender. So if you have a kiosk in a mall and the average age of the person in front of that kiosk is in their 20s, you could sell ad space to companies who look at the demographic for their consumer product as somebody in their 20s. So it really does create very nice, unique, targeted advertisement aspects and chances. The other aspect is also vending machines. So utilization and marketing activities by gathering customers' attributes again, such as age and gender, and then connecting them with the products they purchased. So if you have a vending machine, you might always come back and see that, oh, a lot of people are buying Coca-Cola, Diet Coke, but not a lot of people are buying Sprite. And then you can maybe even say that, hey, the average age is this, the average gender is this, and maybe that is the data behind their reasoning for purchasing that Coke or that Diet Coke. So it's all about being able to connect the demographic data to that person's choice of beverage or food or whatever is offered within that vending machine. Also, a lot of vending machines now have also advertisements. So as somebody in their 20s and as a female walks up, they can supply or provide different beverage choices based on that demographic or that person who's in front of the vending machine. Maybe if it's somebody who's older, we offer them a coffee choice. Maybe if it's somebody that's younger, we offer them a Coca-Cola. So it creates another unique atmosphere to really try to target the market with unique products within that vending machine. And hopefully at the end of the day, it helps push more products for that vending machine, making more money for the companies. So in addition to advertising those kind of aspects of facial recognition, we're also starting to see it used in kind of a legal compliance assistance aspect. So a lot of the times where I live in Illinois in the Chicagoland area, and a lot of the times I go to my restaurants, my gas stations, the convenience stores, I see a lot of areas for slot machines right now. A lot of those slot machine areas have a big sign or a piece of paper that says that area is restricted for 21 years or older. It's just a piece of paper. There's no other aspect to that area that is stopping me from entering and sitting down at a slot machine and gambling. So to help provide that extra layer of legal compliance in that kind of space, you could use software to, again, use the age estimation to detect if somebody maybe under the age of 30 is entering that space. Then maybe it alerts the staff to go and do an ID check, where if the age is 30 or over, maybe that secondary ID check is not required. So it could help provide extra alert or that legal compliance aspect to that video gaming terminal that we're starting to see pop up in several states across the US. The next thing is, as Ankit said, a lot of customers will use us to embed into low power embedded devices to ultimately be used on computing devices. So with that, you can actually have our full library to embed onto those ICs. You could use the full function library that includes age, gender, face detection, expression, and so on. Or you can just choose the ones that you ultimately want to use within your package. It's a little bit of a plug and play a la carte menu. You're not always going to have to download the full library if you just want to use certain aspects of our software library. Some two other areas that we're seeing popular use cases for is in that operator verification in factory automation settings. So facial recognition is used to identify the person operating the equipment, and that can help reduce equipment failures or unintentional setting changes caused by somebody that should not be operating that piece of heavy equipment. So what that basically means is if the person or operator is qualified to use certain equipment or have certain requirements that they can change settings within the factory automation area, you could log or update them into the system and create a profile where they are then recognized with OKAO as the correct operator that can do that function or operate that machine. It kind of provides that little bit of security to authenticate that the correct operator is the one utilizing the piece of equipment. With that, you can also use it for traceability. So with our system, it could verify the operator number 2345. And then as they're doing certain settings, that can all be then logged back into the system and kept on for data. So God forbid something happens during that specific shift, you could then go back to your log and see that it was in fact operator 2345 that was the one who input these setting changes that may have led to some kind of failure or some kind of issue. So it helps for traceability on the factory automation or manufacturing setting. The last one that we're kind of seeing pop up is with communication robots. So as robots are starting to get more popular, you see them in restaurants, sometimes delivering your food. Sometimes you see little robotic toys that children or people of all ages can play with. So a lot of the times they will employ some kind of face detection so that robot can then follow humans and create more of that human interaction. So think of your son or daughter playing with the toy. As the toy moves, it will continue to lock faces with your child, giving it more of that human interaction, giving it more of that that interactive, immersive playtime. Or if when you're getting your food delivered to you at the restaurant, maybe that robot turns its face, makes eye contact, and maybe says, "Enjoy your meal." So again, it's hiding in that human interaction with robots to create a better feeling of them kind of joining us in this world. Also with that, you can also recognize human expression. What happens if this robot sees that its owner or person that is sad? It can maybe console that person and offer some guidance as, "Oh, don't feel sad, please be happy." Or maybe if it sees that it's laughing, the robot can offer a hearty laugh to go along with that person. So again, it's creating more of that interaction, more of that immersive feel with the robot. And then lastly, we could also use facial recognition to identify an individual. As you enter your home, if maybe there's a robot, it would say, "Good morning, Patrick, welcome home." So you can do that kind of also in your warehouse as we have AMRs moving along us. It can identify different workers and maybe say, "Hello, Adam, how was your day?" So then we're trying to create this sense of human interaction, making it more humanizing, that interaction that we have with robots. And lastly, I just wanted to say that while we've listed these kind of 6 areas that we're seeing growing and Omron's willingness to support in this kind of market, we are not limited to supporting these applications. There are far more use cases that we are glad to support any kind of requirement or need that you might have. So please feel free to reach out to Ankit or myself to help explore some of the opportunities that you might have with facial recognition. And again, I just want to say thank you, Ankit, for allowing me the time to step in here and talk about use cases. And now I will pass it off to you to bring us home. Thank you.
Perfect. Thank you so much, Patrick, for talking about the real life examples where we have seen recent success or the examples of, OKAO and HVCP2. And I'll reiterate, like Patrick mentioned, that our support is not only limited to just these 6 applications that, Patrick talked about. So moving on, now I'll again give like 5 to 10 seconds to you to answer the poll question that you will see on your screen. Perfect. So now we'll talk about the last solution that we have to offer. We have talked about OKAO and HVCP2. The next thing we want to talk about is our AM1 human detection software. This basically is a software which automatically gathers the human emotion, depending upon the worker act, right? So basically, you can imagine that you have an area, like whether it's a factory or a warehouse or anything, right? And you have divided that into different zones. So basically what this software will do is this will tell you how much time a person has spent in a particular zone, and then it will track that, right? Basically giving you the workers position like X and Y coordinates and the time it has stayed, right? And then you can even think about that if somebody is not supposed to go in a certain zone, like you have marked it as a no-go zone, right? And if somebody goes there, it will give you that alert as well, right? So now we'll see the video of action as well for this, how this AM1 software works. Perfect. So like you could see in the video, right, that, when the people were moving, so you could see on the right that the graph was also moving based on how much time they were spending in those areas, as well as, the movement, like tracking them. Okay, they went from zone 4 to zone 6. So that's what I was saying, that, we can track X and Y coordinates, the position of the worker, as well as their movement as well, right? So now the benefits of this solution, right? So like I mentioned that this is a top view, that means it will go into the ceiling, right? So that will reduce the blind spot because it is top view. It is high accurate, the accuracy is similar to the normal camera, even if we only have a small kind of, feature from top view, right? And then it is a very convenient, it is, easily integrable with the camera and the normal PC, right? You don't need a huge system for that, right? So just to give you a perspective of, I'll talk about the system example of how, this can work, right? So Omron does have, Centec cameras, which is basically an industrial grade camera, which, you can install in the ceiling. And then, those cameras, your space might be huge, right? And you might need multiple cameras, right? So then in that case, you would need a PoE hub for those cameras to be connected, right? And then that data will be given to your host system, whether it's a PC or a PLC, right? And then eventually you can control the things, right? So basically, depending upon how the person or the worker is moving, so that will give all the data to the host system. And in case, like if you have a very small facility and if you just need one camera, you don't need a PoE hub. This is just if you are using multiple cameras, right? So we just wanted to show you a system example, how it will work. The next thing, similarly, like we talked about, the system requirements, we'll talk about the system requirements of AM1 as well. The only system requirement is that the library of AM1 uses Intel OpenVINO. So we would need a system that is compatible with OpenVINO. So that is the requirement. And just to talk about the specification, the detection specification, the maximum detections that can be done in a frame is 10 people. So it can detect up to 10 people, or I can say assign the IDs to 10 people at a given point of time as an output. So let's talk about the specification in a little bit more detail. So like I said, the camera, because this is a top view camera, so this would go into the ceiling. So the camera height is usually 2.5 to 5 meters, and the detection distance is 7 meters side square. That if you kind of multiply it would like 49 meters square, right? So that it can detect. The posture is standing. Right now we can only do standing. And then the average human body height is 150 to 190 centimeter. And then just to give you a talk about, that if there is some occlusion, like for example, if where the person is standing, there might be an object on the side, whether it's a shorter object or a longer object, right? We can still detect the human. So that's the percentage that we have given in terms of if there is a, inferior direction or a superior direction, right? Or if there is a lateral partial occlusion as well. So we can still do the detection. It's not like we won't be able to detect if there is some objects around the human, right? And similarly, if there is multiple humans very close to each other and they are kind of overlapping each other, we still can detect them individually. Like again, if they are very close, they might identify as one person. So that is also kind of a limitation that the occlusion area should be up to 25%. So that is kind of the specifications that we have for this AM1 solution. The next thing to talk about is the application examples for this. So the first application example is analyzing the the working times for each person. Like for example, in a cell production method. So as you can see, so like I would say that a process or an kind of from like a raw material to make a final product, right? You have like 5 to 7 different processes that you need to do, right? In terms of in that pipeline, right? So this will make sure that the worker is tracking or doing all that process in time. Like once you have that, kind of fed into the system. So for example, if you see on the right, like if a person does process A, process B, and then suddenly it goes to process E, it will create the alert saying that nobody did or the person did not do process C and process D. So that will give the alert, and then the person can go back and do that process C and D which he missed, right? That is one application. The other application is you would know that how much time does it take to finish that process, right? Like process A, for example, right? So you can also track, like I said, we give how much time a person spent on that, right? So it will tell you how much time that person is taking to do that certain process. So in that scenario, it will give you the worker productivity as well. Like for example, if a process takes 5 minutes and the person who's actually doing it, is taking like 15 minutes, for example, right? So you can actually, check that productivity level as well, and make sure that is addressed. The second use case for this application that we have seen is the efficient layout of analysis of workers in a flow line, right? So consider a case of logistics warehouse where we have material shelf and people want to either grab something or place something, right? And so sometimes as you can see in the image, right, people might be crossing, kind of overlapping each other, or there can be multiple people in the path, right? Because, or overcrowding, right? So to avoid that, right? So it can actually tell you that, okay, this path, like trace the path of the worker, that, okay, to go to shelf H, the worker, took from A to B, C, D, H, like all the cross all the shelf, rather than, he could have taken that route, which would have been, less crowded, and it would have taken him lesser time to kind of do that activity. So this software basically can tell you that as well, like track the workers movement as well. So these are the two applications that we are currently focusing on. Obviously, like similar to OKAO, there are other applications as well where this software can be used. Now you would see another poll question on your screen, so please answer that. I'll give again 5 to 10 seconds for that. And with that as well, this concludes what me and Patrick had to talk about today, and I would like to hand it back to our host today. Thank you.
All right. Well, thank you for that in-depth presentation. It was fascinating to see the detailed information that comes out of that OKAO system, all the data it can pull from the images, and the safety application, I think, what really caught my eye. But I'm going to be interested to see how this capability enables new applications in the coming years. I noticed in the first poll result that the audience was tagging a lot of different applications. So there's a lot of work going on here. So we've got a lot of great questions already, so I'll remind everyone there's still time to submit your questions, and we'll try to get to them. Just type them into the Q&A section on your screen. Ankit and Patrick, are you guys ready to answer some questions?
We sure are.
All right.
Yes.
All right. The first one is asking, how precise is OKAO in determining gender and age from the detected faces?
Perfect. I can take that. So to answer that question, to get into specifics, I would need an NDA, but I can give you like a general overview for that. So for accuracy for gender, it is almost around somewhere in late 90s. And for age, because we give exact number when the demo is running or when the evaluation people are doing. So for exact age, it is somewhere around 80 to 85%. But you can increase that accuracy if you kind of put an age range rather than displaying the exact age of the person who's in front of the camera. If you kind of make a range like 0 to 20, then the accuracy will increase. So I hope that answers the question.
Makes sense. All right. Our next question, is there a function for fire detection?
I could take that one. So OKAO wouldn't have a function for fire detection per se. But within our sensing portfolio at Omron, we do have a D6T thermal sensor. While that thermal sensor could be used to detect temperature spikes in a given space that it's sensing, it wouldn't be able to detect smoke or anything, but you could use the thermal sensor to indicate if there's that sudden spike, of temperature that would maybe indicate a fire is present within that space.
All right. This question is asking could the AM1 be used in safety applications?
Perfect. I can take that. So if you are talking about a primary safety, maybe not, because we don't have any kind of safety ratings with this. But for secondary, safety applications, yes, absolutely, it can be used.
All right. What is the accuracy of the OKAO functions?
I think, like I addressed it before, to get into very specifics, we would need an NDA, to kind of answer that question. However, we always recommend that, customer can get a demo or evaluation SDK and they can evaluate the accuracy themselves, right? But if they need from us, we do have our own internal database from which we have evaluated the accuracy, but, we can provide that once we have the NDA with them. But obviously the accuracy will depend upon the input, images and the parameters that has been given. So.
Okay, very good. Our next question is asking is, what are the advantages of OKAO over other solutions that are available out there in the market?
Right. So as I think we mentioned during I think Patrick also addressed to that, right? So our OKAO is specialized for embedded, systems compared to competitors and, open source solutions, right? So it can run with, so the advantage that we see is that it can run with low resources. What I mean by that is, CPU power, which is power consumptions and memory. So we don't require, high power or high memory to run our software. Basically, it is more CPU driven, so we don't need a GPU to run this, if that makes sense.
Sure. What is the pricing structure for OKAO solutions?
I can take price. So there's two different pricing structures that we can move forward with. The first one would be an annual price that's usually independent from the quantities. It's just a one-time price per year. But we can also offer a secondary option as a per unit license. Depending on the quantity of licenses you would want to have and the functionality tied to each license, we could work out a per unit/license price as well. Typically, that's something that if you guys want to reach out to your Omron sales representative or Ankit and myself, we can kind of work directly with you, because it is based on what kind of functionality you would want to include within that OKAO library.
Very good. Before I jump to the next question, I'm curious if you guys had a chance to look at the poll results and if there anything jumped out at you in the poll answers from our audience.
So I think you hit on it for me a little bit earlier, that the amount of different applications and different areas of focus that have brought our audience here today. I like to see that. I want to get facial recognition, our software, out into all of the markets. So it's very interesting to see that the audience here today is really covering a lot of different markets where we can play with facial recognition software. So we'd like to see that kind of involvement.
Gotcha. Anjit, how about you? Anything on the answers?
Well, Patrick mentioned that, we have, audience that caters to different, kind of applications, what they're looking for, right? So obviously, Patrick did talk about a lot of applications in OKAO, like 6 of them, right? But we would like to see, if we can, find something more out of this, right? So that's something, I'm looking forward to, and see, how Patrick and I can help with that.
Yeah, I think the one for me is that nobody selected legal compliance assistance as one of the things. It's like, because engineers don't think about that, but if they brought their legal team in and showed them the capability, I bet that answer might quickly become different.
Yeah, and I know that when we were diving into that side of the market, it's not that surprising, because in the state of Illinois, for instance, these establishments, in order to comply with the legality of it, all they do need is that piece of sign or a piece of paper that says this is age restricted area. Please enter only if you're 21 or over. So right now, that is the current legal standard that's in place. That might evolve. That might gear more people to wanting to use facial recognition. We're hoping to see that trend start to take off. But I know that the state of Illinois has to kind of implement some new law that helps us.
Yeah, well, there's certainly an overlap with safety opportunities too, I would think.
Correct.
All right, we'll jump back to the question. Thanks for that, guys. This one is asking how to evaluate OKAO.
Right, I can take that. So a customer can evaluate OKAO, so they can do either by a demo software or, kind of an SDK, right? Software development kit, what we talked about. So in order to evaluate through a demo software, we do have, like I mentioned in the presentation, right? We do have in Windows and Android, and they can do that. And for it would be good to, kind of evaluate for accuracy standpoint, right? But if you are looking for, evaluating the processing speed, so the recommendation would be to, have an evaluation SDK based on your platform or your kind of, system. And then, you can, kind of evaluate that to give you the exact results of the processing speed. However, all these things would be done after the NDA is concluded.
Okay, that makes sense. All right, does Omron just sell OKAO as a software, or is it also available as a complete module?
Right. So we do sell OKAO in 3 different forms. The one, like I think a couple of them we talked about today, one was OKAO, that is software IP. The other one is a plug and play camera module, which is HVCP2 component. And the third one, usually how we do is hardware IP, which is RTL designs, which is registered transfer logic designs, which basically directly embeds into the chipset of a customer.
Okay. This one is, what's the maximum number of people that HVC P2 can recognize?
So HVCP2 can recognize up to 100 users with 10 images per user. So we recommend to get the best accuracy, right? So we recommend to have 10 images, kind of stored with different angles and different lighting conditions, so that it is highly accurate. But obviously, if a customer think that, they don't need 10 images for every user, they can reduce that and increase the kind of the capacity of recognizing people. So the total bandwidth that we give is 1,000 images album. So that's what the bandwidth is.
Yeah, I'm going to kind of follow up on that with my own question that came to mind is, do you guys provide recommendations for like the angles and the lighting to really fill that out for people building their data?
Yes. We do provide recommendations. Yes. So we usually say, front, side profiles, like both left and right, then maybe like upper side and then lower. So we do have different, recommendations that we provide, to kind of, get the best accuracy.
Yeah. All right. This one's continuing on the HVC P2. It's asking is, what is the current and power consumption for that device?
Just to kind of reiterate, so the current is under 0.4 ampere and power is under 2 watt, and this is kind of a very low power and low current consumption device.
Yeah, which is important for these embedded applications you've been talking about.
Absolutely.
Could you briefly talk about the OKAO architecture on the hardware side and the hardware specifications and what it looks like, size and interface with the camera?
That's a big question. So I'll try to address, one by one, right?
Yeah.
So OKAO is a software solution, and it can work with any hardware. What I mean by that is the system should be like I think mentioned in the slide, is the hardware requirement is either 32-bit or a 64-bit system, right? So just to put out some examples, that OKAO can work with any system like Windows, Linux, Mac, RTOS, that is real-time operating system, Raspberry Pi, anything you can think of which is 32-bit or a 64-bit system. And the system doesn't have to be, OS, dependent. So it can be OS independent as well. What I mean by that is, if it isn't, if there is no OS as well, it will still work. The requirement is 32-bit and 64-bit. That is, I think, the first part about the architecture and the specification. To talk about how it interfaces with the camera, it depends, what the customer is using, because with OKAO, it's a software library, right? So we don't typically, kind of have restrictions about, the camera and stuff. What we say is typically the camera should be, the higher the resolution of the camera is, the higher accuracy is, because you can see it clearly. But if it is a very wide angle camera, then you might see a little bit of noise in that in terms of accuracy. So we recommend, it should be a normal, viewing angle rather than a very high, I mean, if that answers the question with interfacing. So
yeah, I think that helps. Well, and speaking of cameras, I think this leads into the next question does the AM1 software only work with the Omron Centec camera?
No, AM1 software can work with any fisheye lens. Obviously, we have to customize the software for a normal fisheye lens. Currently, it can work with Omron Centec camera, and that is our recommendation as well, because that is like a complete solution that we provide.
Very good. Okay. And what is the requirement to use the AM1 software?
Okay, so for AM1, I think I did touch base on the slides, but AM1 system requires a system that is compatible with OpenVINO. That is basically an Intel-based library. So OpenVINO 2022.3, and other additional requirement would be to have an industrial camera with a fisheye lens, or any other camera which has a fisheye lens. Industrial camera, because they are like robust and rugged, right? So that's the reason I put industrial camera.
Very good. I want to let the audience know that there are the handouts available. You can get those in your upper right-hand corner. While we give them a chance to download those, Ankit, Patrick, any last thoughts you want to share with the audience?
Ankit, you can go first.
Well, I was not prepared for that question, but so just like I said, this is just just to reiterate, this is the basics of what we could share in terms of our technology that we have to offer in AI. Obviously, AI is a huge domain, right? This is what we are focusing here is on human vision image sensing, and we are trying to address some of the challenges that that people face, or we have been hearing from our customers that they are facing these challenging, whether it's engineering resources shortage or whether it's customization and flexibility. So we wanted to kind of talk about that and address it with our solution. So I think I hope we were able to do justice with that.
Well, that was a great answer for me, springing that on you with no warning. So, Patrick, how about you?
Just to kind of reiterate what Ankit said, I know within my daily life, I'm starting to see a lot more cameras on kiosks, a lot more cameras at the Starbucks when I place my order. So as we move into this, new age world where cameras monitoring facial recognition is becoming more prevalent, please remember Omron. We have a very nice OKAO suite of functionality. So as you kind of look to adapt certain aspects to your product, just please reach out to Omron and remember us, and we'll be happy to assist and support anything that you guys bring to the table. So thank you.
All right, very, very good, guys. So thanks for your presentation, that great discussion, the Q&A, and thanks to our audience for your participation in the Q&A and those polls. We really appreciate it. So in just a moment, you'll be redirected to Omron's author page on All About Circuits. You'll be able to view this session on demand by using the same link you used to view the webinar. Thank you, everyone, for your time. We look forward to seeing another live session again sometime soon.
Thank you guys for your time.
Thank you, guys.
Have a good day, everybody.